Hey everyone! Today, we have some groundbreaking news in the world of particle physics. Recent experimental results have shown that muons, which are heavier cousins of electrons, can be corralled into beams suitable for high-energy collisions. This advancement could pave the way for a new generation of particle accelerators, offering more compact and cost-effective alternatives to the massive colliders we currently use. Let's dive into the details. Welcome to Trendstorm. Chapter 1. The Importance of Muon Technology. Particle accelerators are vital tools in various fields, from probing the fundamental makeup of matter to treating cancer and manufacturing silicon microchips. Traditionally, these accelerators use protons, electrons, and ions. However, muons have the potential to revolutionize this field due to their unique properties. A recent analysis led by researchers at Imperial College London, as part of the Muon ionization cooling experiment, MICE, collaboration, has demonstrated the success of one of the key technologies required for muon accelerators. This breakthrough paves the way for the development of muon colliders, which could be cheaper, smaller, and capable of reaching higher energies than current accelerators. Chapter 2. The Power of Muon Colliders. The Large Hadron Collider, LHC, is currently the most powerful particle accelerator in the world, using protons to smash together at high energies to discover new subatomic particles. To achieve even higher energy collisions, a much larger proton collider would need to be built. However, this would be incredibly costly and time-consuming. Muon colliders offer a promising alternative. They could reach effective energies as high as those proposed for larger proton colliders, but in a much smaller space, making them more compact and cost-effective. However, to make this a reality, technology needs to ensure that muons can be collided frequently enough. Chapter 3. Challenges and Solutions in Muon Acceleration. The major challenge with muon colliders has been getting the muons to congregate in a small enough space to form a concentrated beam for collisions. The MICE collaboration previously produced such a beam by using magnetic lenses and energy-absorbing materials to cool the muons. The new analysis of this experiment looked at the shape and size of the beam in more detail, confirming that the cooling successfully made the beam more perfect by reducing its size and organizing the muons' travel. Chapter 4. Promising Results from the MICE Collaboration. The experiment was carried out using the MICE muon beamline at the Science and Technology Facilities Council, STFC, ISIS Neutron and Muon Beam Facility in the UK. The team is now working with the International Muon Collider Collaboration to build the next stage of demonstrations. This positive result gives confidence to move forward with larger prototype accelerators. The goal is to deliver a muon collider as soon as possible, potentially transforming the landscape of particle physics research and applications. Source: Imperial College London. If you found this video informative, please like, subscribe, and hit the bell icon for more updates on the latest scientific breakthroughs. Let us know in the comments what you think about this exciting development and its potential impact. Thanks for watching, and see you in the next video.